So in this video, I want to go over dividing and subtracting exponents. So let's say you have a problem like x to the 12th power divided by x to the 8th power. Well, they have the same base of x, so what we can do is just subtract the exponents. So this would actually end up being x to the 4th power would be the answer. And the reason why this is true is because we can rewrite this problem, right? Let's say we can rewrite this problem as x to the 12th power times x to the negative 8th power, right? And if you recall from my earlier video, right, when we have the same base, both x and x, we can just add the exponents. And 12 plus negative 8, right, will give you 4, right? So you'd end up with x to the 4th power. So let's do some more examples. Here we have x to the 8th power divided by x to the 5th power. So because they have the same base, both x and x, I can subtract the exponents, right? So I can rewrite this equation as x to the 8th power times x to the negative 5th power. And that would give me x to the 3rd power. Let's do some more. So here instead of x's we have y's, but the concept is still the same. We have the same base, right? So we can subtract the exponents. So I can rewrite this equation as y to the 10th times y to the negative 2, and this is just going to equal y to the 8th. Alrighty, let's do another one. Let's say we have 5 to the 25th power divided by 5 to the 10th power. Pause, take a minute, see if you can figure this one out. Okay, if you guessed it, we're just going to rewrite 5 to the 25th power times 5 to the negative 10th power, right? Because anytime we take this exponent and we bring it up, it becomes a negative. So that's all that's going on. So we have 5 to the 25th times 5 to the negative 10th power. This is just going to get 5 to the 15th power. Awesome. Let's do some more. Let's say we have 8 to the 64th power divided by 8 to the 32nd power. What do you think we're going to do? I thought I heard it back there, right? So we're going to rewrite this equation in terms of 8 64th power times 8 to the negative 32nd power, since we're bringing it up from the denominator to the numerator, right? And then we simply, right, same base, so we can add the exponents, right? And this will give 8 to the 32nd power. Let's do another one. So this is just in terms of a's, and it could literally be any variable. It could be a, it could be b, it could be c, it could be x, it could be y, it could be z, right? The point is that we have the same base, right? So we can subtract the exponents. Now, our exponents are just simply m and n. So that's pretty much, there's limited things we can do with this equation. All we can really do is rewrite the equations as a to the m power, right, minus n. Essentially, because if we were to rewrite this, right, it would be, right, if we were to kind of rewrite this equation, we just get a to the m times a to the negative n. We don't know what m and n are, so we can just leave the equation as a to the m minus n.